So for you guys' first step, did you take your stuff that were given to you to moles? Did you take what was given to you and convert to moles?
Yeah.
The first one was probably easy with the copper. You can take your grams to copper, 2 moles of copper fairly easily. You're an old pro at this. So you should have approximately 0.03933, something like that, right? You can extend your math out as needed. But you should have moles of that one, and this is what you'll label as have, right? This is your have. This is how much you have of the copper before the reaction even begins. And I'm going to show you how I'm going to model this on the board as well. This next one, who did get started with the molarity and the volume? You said, I know one thing about that, and I know if I multiply them together, it will give me moles every single time. So if you take your now, the milliliters are the misleading part. You do need to take that to liters first because this molarity is moles per liter. So molarity has liters in it. So your milliliters have to be converted to liters. Your liters will then be multiplied by the molarity, which is the big M. Big M broken down to its individual units is moles per liter. So liters then cancel. So what is that? 0.4, or 0.04? 00. And this is moles of silver nitrate. And this is how much I have before the reaction begins of silver nitrate. So give me a thumbs up if that first part is okay. Maybe it's not like I feel great about it, I get it tattooed on my body, but you feel okay about it. Okay, so I want you to, maybe on a separate or on corresponding parallel paper that you can kind of see both on, I want you to model organizing your information in a chart. Okay, so that we can see, you can pick your poison at the end of this, but I'll show you both of them. Write down the same reaction and put BDA, and I'll tell you what this means. I want you to have this so you can actually pick at the end if you're informed enough to pick which way you like to do it better. So B means before the reaction begins. So before the reaction begins, how much do I have of everything up here? Before the reaction begins, how much do I have of everything? My copper, my silver nitrate, my copper 2 nitrate, and my silver. Tell me what you know. Yeah.
2.5 grams of copper.
Okay, now I could put 2.5 grams in here, but I am going to tell you that you don't put anything in here unless it's in moles. Okay, so let's call this our mole before, during, and after chart. Because we've already converted our grams to moles, right? If not, I'm going to have to do it again, and nobody's got time to do that twice. So, thank you, Lindsay. We have 0.0399, 933 moles of copper. Okay, how much do I have of the other one? 0.04 moles of silver nitrate. How much do these products do I have before the reaction begins? Great, you guys are saying nothing. Nothing. There's no products because the reaction hasn't even started yet, right? You can't have something until the reaction's actually gone through to completion. So I have 0 before the reaction, that's B, of both of my products. Now, for a limiting reagent problem, what do you know happens to one of the reactants? Runs out. So one of these, either copper or silver nitrate, one of them after the reaction is going to do what? 0. Oh, that's our job to figure out which one by doing what? By doing limiting reagent. It's so vague. What does that mean with these?
One substance.
Okay, so we are comparing through mole ratios the amount I need of the other reactant to fully react what I have here. And you guys have been doing that with mole ratios, meaning multiply by your coefficients as according to the copper needs to be converted to how much the other one I need, which is silver nitrate. So what ratio to put here? 2 to 1. All right, so that's 2 moles of silver nitrate, thank you, and I'm writing really small so I hope you can see that, converted by taking 1 mole of copper as a comparison. So the moles of copper truly cancel, and this tells me my need of what? Silver nitrate. So what's that times 2? 0.0786 moles of silver nitrate. Okay? I'm really squeezing it on the board here. I need 2 smart words. Okay, so that's how much you need of the silver nitrate, and then comparatively, you do the same exact process, except what do you do with the coefficients here. Do you use it as 2 over 1? You do it as 1 mole of copper over 2 moles of silver nitrate, because you're comparing the reactants, so you do have to be utilizing the 1 and the 2 here. So, Caleb, what's that? Thanks, sir. What's 0.04 divided by 2? 0.02 moles of, of copper that I need. Okay, so that's how much I need of copper, that's how much I need of silver nitrate. So with this, now you compare from the opposite ends of the spectrum, the two haves and needs together. I'm going to try to highlight this so you guys can see this a little bit better. So I have this much copper. How much copper do I actually need to fully react with the silver nitrate? 0.02. Okay, what can you guys tell me logically about this then? So why am I going to have excess? Right, you got a bunch extra. You only need 0.02, you got 0.039. We're good. We're going to have excess of that. So immediately when you figure out that's your excess, what do you need to write down? Above your reaction. Probably you want to label that, right? Because we went through all the hard work to figure out this is our excess. Oops, I just put XL. Excess. So then the other one has to be what? The limiting reagent. Okay, so let's prove it to ourselves though by doing the other comparison. So the silver nitrate, how much do I have? Silver nitrate, how much do I have? 0.040. Okay, label that for yourself or highlight it or star it. And then compare that to how much you needed the silver nitrate, which was only 0.078, and I got 0.04. What's going to happen here? Yes, you have less than what you need. You need a lot more. You're going to run out of that very fast. So that's going to be your one that runs out, meaning we call it the LR. Okay, so we can organize it like this, and I've highlighted, I've kind of tried to help organize it, but it gets messy, right? It really does. So another way you can try to organize it, and this is a little bit more advanced, but if you are moving to AP chemistry in your life or going to college chemistry, you'll see something like this, not necessarily like that. There are like 3 or 4 ways to teach the limiting reagent, and these two are very comparable. So during the reaction, what's happening to the LR? It's getting wiped out, right? So here's my LR, silver nitrate, right? Copper's my excess. So all of this gets subtracted. 100% of this is wiped out. It's gone. So subtract 0.0400 moles, and you should have 0 left of that after the reaction. So it's just a simple subtraction problem. All of that's wiped out. But during the reaction, how much of the copper are you actually using? How much of the copper are you actually using? 0.02. And you knew that because we just converted 0.04, and then Caleb said divide by 2 because that's your ratio, and you said you only need 0.02. Now that whole process you can write in this box. So what I'm saying to myself is I'm using because it's the LR, I'm using the same amount of the LR, which is 0.04 moles, but in a ratio of 1 to 2. So I'm subtracting the full amount of the LR, but in the correct ratio, which is 1 to 2 ratio. Guess what that is? What's 0.04 divided by 2? 0.02. You just did it here with more like words. You're like, oh, I'm going to use this much. I'm going to convert it from what I had of the LR to what I needed of the other one, and so forth. But really, this is exactly what you're doing. So if you like that way better, stick with it. But I'm showing you another tool as well. So 0.02 is what's being subtracted. So taking your calculator in your head, 0.03933 minus 0.02. Yes?
Can't you always just subtract what you need?
That's what this is right here. But that's you finding need, and then taking what you need and put it here. I'm showing you how to calculate need and subtract at the same time. It's a little bit more advanced though, okay? So this is my LR amount, and this is my need. All right, how much is this? Yeah? 0.01933. Don't be losing my sig figs now. I need those. Okay, so after the reaction, this is how much I have in excess, right? This is my amount of excess left over. Question? This right here? because I'm taking the amount of LR moles and I'm converting it in one box to the amount of this one that I need. So I took my 0.04 times 1/2, which is exactly what I did here. 0.04 times 1/2 to give me 0.02. I just modified it so it doesn't have all the units in it over here. Okay, so this is how much I have in excess. This is how much I have at the LR at the end, 0. You're like, I knew that. And then let's look at our question and see what this is actually asking, because this is organizing our facts over here. So question, what's the limiting reagent? We got that. How much silver can be recovered from the reaction? Well, what is that really asking? How much silver can be recovered? Grams of silver. It's actually just asking grams of silver. Where's that out on here? Product. Okay, so it's not the before the reaction. You got some stuff happening during the reaction, right? But really, that's this box right here. After the reaction's over, how much silver can I make? So that is grams of silver. That's our question. The other question is, how much of the reactant's left in excess? Dun dun dun! Don't we have that? We have our moles in excess, but you could easily convert that to what? Grams of the copper, because remember this column is referring to copper. And then what's the percent yield? We'll figure that out at the end, because it does relate to part B and part D, because it's both talking about silver here. Okay, so normally, make sure I don't write on the board of the expo marker. Normally at this point, after you've done all this work, what do you now, why did we do this? Because how are you starting the next part of the question? Rishi. Well, actually, let me find silver grams first. But what do I start with? I mean, there's like 4 numbers up here. Which one do I start with? The limiting reagent, what? Half. Okay, please write down for yourself. Start with LR half, because that will always be the starting point. But you just have to make sure you've labeled appropriately throughout so you know what you're doing here. So what's my LR half? Who's my LR? Silver nitrate, right? Silver nitrate's my LR. I have 0.0400 moles of the LR, silver nitrate. And you guys have your reaction in front of you. I don't. What's this? Assuming the question is we're going to grams of silver, what do you need to do first? Mole ratio from silver silver nitrate to straight up silver. And that ratio is 2 to 2. Now I know you're like, oh, it's just 1 to 1, I don't have to write it. No, you do have to write it, because you're respecting the fact the units need to be converted. So there's 2 moles of silver according to my balanced chemical equation. And there's 2 moles of silver nitrate according to my balanced chemical equation. Your units of moles per silver nitrate, they cancel. Now it's my last step. Right, so my question here was to go to grams of silver. And that is that last step. So 1 mole of silver was 107.868. 86. Never mind. I was on the right track. There we go. So 107.86 grams of silver. And so you guys calculate that for me, because I can't do that part in my head. 4.3 what? 1. Okay, I'm just going to put 4.31 grams of silver. 4.31 grams of silver. So, I'm going to show you how this is represented on the little BDA chart over here as well. So far, during the reaction, okay, before we move on, during the reaction, who's controlling the entire reaction? The limiting reagent, right? So what you'll notice is I'm taking its moles, and I'm using it every single time during the reaction. Because that's the controller, right? It's controlling it, but it's also respecting that these ratios are all different than itself. So I subtracted itself from itself. I knew I got 0. I subtracted the other reactant, because reactants are consumed in the reaction while products are produced. I subtracted it in a ratio of itself, but 1 mole of copper for every 2 moles of the silver nitrate. I just didn't write all the units because it's a little bit small over here. But then I'm adding to the product side, because I'm producing products. And I could do the copper 2 nitrate one, but that's not my question, so I'm actually going to go straight over here. So I'm taking the same number, but I'm adding it in a ratio of what to what? 2 to, look at itself, right? It's always reflected back to the LR. The LR is the shining star here. So the 2 the column you're in is referring to silver, and that's 2 moles of silver, over 2 moles of the silver nitrate, so it's a 2 to 2 ratio. And didn't we just do that? Yeah? We we just did it, 2 to 2. Now, I'm going to stop and just make everything here moles, and of course you could easily convert to grams, so that's like old school for us. But this is 0.04 moles of silver made. That's how many moles of silver are made. That's how much excess copper is remaining. This is how much limiting reagent is left, 0, and then we just didn't have to deal with that one because it wasn't in the question. So from that aspect, though, you would have to definitely convert to grams because that's our question in part 4. The part 4 says, what's the percent yield if 3.64 grams of silver is recovered from the reaction? What is this right here? Actual yield, because it's saying percent yield, so you're like, oh, stop. If I have percent yield, I have to have 2 other things. I have to have actual yield over theoretical yield times 100 to equal percent yield. So if I already know that theoretical yield is la la land on paper, don't I have it someplace else here? Don't I already have theoretical yield? What is it? 4.3, and this being actual yield makes sense because I have to have the reaction, and I can't make like Rishi get them like, man, go figure out how much actual yield you can get in the middle of the class, right? We have to have it in the problem. So 3.64. Was it 6.4? Did I just, okay, making sure I read that right. Is actual yield, and what we just got here for the silver is theoretical yield. So let's figure out what kind of yield this is. 4.31 grams. Remember, the units just have to be the same, grams over grams. 84.45%. And that's not too bad, right? I'd totally have them in my lab if I were a pharmacist or something trying to make some product here. All right, so take a minute to absorb that and how what we've done here with have need relates to this. Yeah.
So why did you have 0.04 of silver?
Because I did a 0.04 times a 2 to 2, which is a 1. But remember, this is a before, during, and after chart, and it's like this only has moles in it. Because I could easily just go, oh, well, let me convert that to grams, 107.86 grams per mole. And you could do that final step. This is just help organizing your information. If you like this, organize your information this way, and it makes a lot of sense because that is exactly what we've done here. It's just some people are very visual versus like I can't find a word on my paper, much less explain what's on my paper. Okay, so just another alternative for you. All right, take a couple minutes. You guys have problems at 12. You should have it on your desk. Please talk to the people around you and verbalize your questions and verbalize your answers. Don't just try to tell them the answers. Walk them through a process. So please go through that a couple minutes.
I did the last five. But it says, does this do so it was referring to the ones before? And the one before 8.5. You'll cancel it out and it will get
So honestly, I haven't gotten 4 yet. So tell me if you can hear it because I have not been able to. Do you know how to do something?
Let me ask you about requirement.
Thanks, sir.
Did you make sure?
We're going to go to the lab. Can I get kind of take like little questions.
So you just use that. Yeah, I got 80. I was like, just convert it into a number.
You just convert it
What's their H2?
How did you see the two? I like started it on I was the
I looked it up and I saw it.
I was like dying.
Alright, so it's right here.
So knowing that you need to do a little bit more problems at 12, if you want to start another one with here right now, then you can do that, but we're going to move here shortly and show you kind of
Okay, is this wrong or is this typo or is there something wrong with the end of the year?
that which one?
I keep getting 29.
I'm sorry, can you tell me which question that is?
Four.
It could be a charge difference, but hold on.
I've seen it too. I've seen it. Yeah, it's a
What do you, which question is it? For what? For A? Are you using the right molar mass?
Wait, why is it a 3?
Because it's balanced.
NH4?
No, that's ammonium. Ammonia is NH3. Can I answer a quick question on bounce move equation? Because we eventually are moving to the lab, but I need to give you some feedback first. Like number 4, ammonia is NH3. What about, I think there was a question on number 3 for the iron and copper one. Iron and copper, anybody? Really tiny, but I have my work up here to show you if you need some help. Yeah. Yeah. And if you need a verbal explanation of the LR half need, I think I have it here for you. That's pretty detailed. So get your half to moles by conversion. Get your need by mole ratio conversion to the other reactant if you're concerned on that process. And then talk to yourself and compare who will run out first. That's a little bit vague, but I think that if you're comparing the half need, that makes sense. So I'm gonna leave that there if you want to take a picture, but it's also videoing. So that's the last step of the LR where you're like, I've gotten it, but I don't know what to do. So, and then you always start with, let me really quickly write, start with LR half. So wrap up whatever you're doing in like 30 seconds, please. 39.
So I didn't have like aluminum by itself, but so that's the ones I did like just in case of the metal on. Do you want to go to my place?
I'm scared.
The hissing out. Gosh, it smells like propane. Okay. Let's switch modes here, guys. Chew the yummy. Oh, okay. I have a joke for you too. The yummy s'mores. But what's the chemist's favorite tree? Stoichiyama tree. Okay, thank you for the slow clap. Okay. For our s'more geometry is an educational experience. We are using a Bunsen burner because that's how s'mores works. You do need to have your glasses on for fire because I like your eyebrows. They all look really good, so I like to keep them there where they belong. Burned hair smells really bad. You've ever done that? So it shouldn't take us more than about 30 minutes or so to walk through s'more geometry. The lab sheets are on the desk in the back already, and you need to do that on a separate sheet of paper. So if you want to go ahead and pull a piece of paper out, call it s'more geometry lab. This is an easy lab. There will be some math conversion, so you might want a calculator. But first you must balance your s'mores equation. You'll see it on the back. It's nothing fancy here. It's just a balanced chemical equation for s'mores. Think about the reactants and how many s'mores you're making. Let's start with getting enough reactants to make one product, so one s'more, and then you'll start to kind of decompose your s'mores while you're eating it and thinking, and then doing some math, and then we'll do another one. We'll try to hit 3 of them. That's a lot of breakfast s'mores, but we'll try. Okay? So as you're moving through that, I'll leave this right here for you. You guys can. I'm going to have the supply station be the back middle lab station on just one side. The other side is free, but you do need to get in groups of probably 3. Okay? If you have things that you brought, leave it for the class so everybody can kind of use it, and I'm giving you extra credit, so I just got to make sure I write your name down. So if you're ready to go, let's party, people. So bring it back here for me. Bring it back here. You guys.
All right, let us grab our s'mores and find light. Yes, more.
Bring your s'mores to this table.
Not gonna
I'm
run.
right here. This table right here. Please go to your last station. Yeah, please three. And if you guys, you can spread out some. There's plenty of spaces. There's a whole other table here that looks like this stuff. So I'm going to help bring stuff to you. But just start by dropping things off so I can actually know who's in your mobile name. Thanks, Nick. Please go to your station now, and I'll call for one person. I'll call for one person. You are going to have to know what you mean. Set up your Bunsen burner, let's go! Tim's table, somebody send me your materials mix. One person or 2 people. Yeah, I like that.
You know, doing that, I don't know.
Guys, don't light it yet. You're not quite ready. You probably haven't even written down your reaction yet. Guys, please don't come see me just yet. I will come see you. I promise I'm trying to pull these materials for you guys. EJ, get me going. Come here. As soon as I look at your reaction, you can start lighting up your smoke. I mean, your Carson, your
Well, it would also be a 1-to-1 ratio. 1-to-1. Yeah, or you can do one. Just like two fractions apart. I mean, you don't have one chocolate. Because you break the chocolate out.
Alright guys, I'm going around to see your reactions. Don't come to me right now. Just wait 1 second. Because I can maybe do this orally versus come to each of you. You ready? Everybody should have goggles on. If you don't have goggles on, you can go sit down in your seat. You're not following the rules. And then also, Miles, give me one of the reactants. 2 graham crackers, but 2 GC. But it's 2 separate ones, so I do think that even if you take one, you break it in half. I'm calling that 2 now. Okay, 2 graham crackers. Chloe, tell me something else. 1 marshmallow. That's the correct reaction. Plus, give me one more thing, EJ. 2 chocolates is a little bit gluttonous, people. Let's go with 1 chocolate. Sorry, so that's going to be our limiting reagent. We're going to run out. So 2 grams plus 1 M for marshmallow plus 1 C for chocolate makes 1 s'more. Don't worry about trying to jumble the letters together to make it balance, because it's not going to balance. Don't get crafty on me. It's just 1 s'more. Use those ratios throughout all the problems on your sheet. So before you can begin, you'll notice that it has only one of the worksheets has this. I'm so sorry. I have the same line except 2 different pre-layout portions. You guys see the table at the top? The table at the top says number in baggie. This is just an example. Using the number in the baggie, 25, 10, and 60, think about how many s'mores you can make based on the ratio. So that's like 25 moles, 10 moles, and 60 moles. Figure out how many s'mores you can make based on the ratio. And you can begin by lighting your Bunsen burner and being safe and starting your reaction. And I'll start passing out more things as lost your first stash.
So is everyone using the same map for that chart?
There's like, can we have some of those live sheets in here and one sheet is like 3 or 4 rooms? Goggles on, please.
I love my giant I'm sorry. Yes, we're gonna use the giant orange phones. Those are more fun. Yes. I know those are more fun.
If you have a flamethrower, you need to turn your gas off and then reflect with yourself how to fix it.
Are we sharing?
Yeah, share that right now. There's enough at your table.
We are best marshmallows. No, we don't get one. We need one drop. I know, but it's not this one.
To the point where you just don't.
For goes for everybody? Oh, yeah.
No marshmallows like on like legit fire, because then it has much longer to go off. So just kind of keep it on the video. We're doing camera. Keep it on the video. I can age. Alright, you guys are assembling your think they're on chemistry? Yeah.
Okay, we're done.
Sorry. And cover one chocolate on chocolate and one gram.
Oh my gosh, that marshmallow smells real good. Do you like your marshmallow?
We gotta wait for it to go.
It's around forever.
So guys, I think I need to do I'll bring you more marshmallows, but you will complete this lab. So don't get too caught up in the roasting process.
Alright, one more. So now we just put the marshmallow on. You know how to do it, right? You want to stick them on there? Smush it. Would you like to use the and 3. Big fun marshmallows.
I can take pictures of them. Yeah, slow down.
Wait, oh. Yeah, that one has lucky. Can you use your... Thank you. Alright.
Jillian, it may not be good. Get another striker, another group. Sup? Yes.